Hello, students. It's Mr. Rich. This is my Mr. Rich Q&A on Sunday nights. We go live at 8 o'clock every Sunday. I usually pick a topic and maybe talk for about 15 minutes about that topic and then take your math questions. So if you do have a question for me, I have given you my email there that's coming across the bottom of the screen. So feel free to send a question in there if you've got a math homework problem that you'd like me to work on. If you saw the thumbnail of our live session this week, you saw that what I was going to talk about today and am going to talk today about is the ACT. Now, in our area here, our students are going to be taking an in-school ACT on February 24th, I think it is going to be, or February 25th. There is a nationwide ACT on February 14th. And if you are taking one of the nationwide tests on February 14th, you do have an option when you signed up to take either the digital or the paper version of the ACT. And as it turns out, if you are taking the digital version of the ACT, you will have access to the Desmos graphing calculator within their testing platform. Now, I myself have not seen their testing platform. I'm not sure exactly what it looks like. They don't allow us as adults to sign up to take the ACT like we are able to do for the SAT. I could myself sign up for the SAT and go in and take an SAT test along with students on a national testing day, but can't do that with the ACT. But at any rate, what I want to do tonight, though, is then talk about how could the Desmos graphing calculator help you on an ACT test. What kind of questions might you be able to use it to use on the ACT? What would those questions look like? So I'm going to do that. I'm going to take one of the practice tests, and I think the practice test that I've got pulled up here for us to look at is the digital practice test number 1, which is in their latest Red Book ACT book. And I think that's the very first one there. So I've picked out some problems that we will use Desmos, and I'll show you how it might come in handy. Now, having said that, it is entirely possible, though, that if they are putting out a digital test that is meant to be taken with Desmos, that some of the questions that they would normally ask on a paper test would not be the kind that would be on the digital test. There are some that could be too easy if you've got access to the Desmos calculator. So maybe their strategy will be to give a different format on that test or a different group of questions. And I really think that if they're not doing it for the test in February, that has got to be their long-term goal, because paper versus digital, paper with just your own calculator versus the Desmos with a digital ACT with Desmos, it's got to be a different population of questions that they would be asking you. However, we'll assume, though, for the purposes of tonight, that one of the paper tests that we're looking at could have Desmos used to help you with those problems, and we'll take a look at those. So I'm going to go down here to our first question that I picked out that I wanted to use Desmos with. And actually, you know what? I think it was actually this one. I was showing you the wrong test. This one, I believe, is the practice test number 1 from their Red Book. And the first thing that I was going to look at was question number 1. And I'm going to move myself out of the way here so that you can take a look at Desmos. Okay, so the very first question here says that Cameron took 4 tests and his scores were as follows: 100, 60, 80, and 30. Cameron took another test that was scored X. The mean score of the 5 tests he took is 72. What is the value of X? So if you take an average or a mean of 5 things and the average is 72, I'm just going to use Desmos right here as a graph, or not as a graphing calculator, but just as a calculator. So I'm going to type 72 times 5. That would mean that all 5 of the tests, if the average is 72, that the sum of the tests has to be 72 times 5. So I just used Desmos here and typed in 72 times 5. Now, how did I get the times? Well, I don't really use their keyboard down here. I'm using my keyboard on my computer to type the numbers and also to type the multiplication symbol, which happens to be Shift 8 on a standard keyboard. So I've got that 360. Now, these were the 4 test scores, so I'm going to take those away from the 360. So I'm going to come up here in Desmos in line 2 and do 360, and then I'm just going to take each one of those away one by one, minus, 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 and it leaves me 90, and then that would be my answer, that the value of x, which would be the other test that he took, the 5th test, it had to have been a 90, so that all 5 of them would add up to 360. Okay, so nothing special there. I could have done it on a TI-84, but if you're able to pull up the Desmos graphing calculator alongside each one of your questions, then I would be using exclusively the Desmos calculator as you're working these. All right, let's go to another question that we could use the Desmos graphing calculator on. And the one that I picked was this one. It says, which of the following expressions is equivalent to x squared minus x minus 30? Now, this one is a very simple problem. It's question 5. You're expecting this to be easy. They just want you to factor this. So I would definitely factor it. I would just say that this is, I'm going to have 2 binomials here, x and x. I need 2 numbers that multiply to be negative 30, but yet they add to be the other coefficient, negative 1. And I know that's negative 6 and a positive 5. And I know that this answer is this right here. However, here's where a graphing calculator like Desmos might really help you if you did not know how to do this, or maybe it was a more complicated polynomial function. On equivalent expression problems, where they give you an expression and they want you to match it to an equivalent expression, you can match it instead of algebraically matching it. You could decide to match it by graphing. So if you graph the statement that they just gave you in the question itself, and you graph it as a function, so I'm putting y equals that, and it's obviously a parabola, no surprise, it's a quadratic. But then what you can do is you could graph each one of the answer choices and see which one perfectly coincides with the graph that represented the original expression. And so if I do x plus 3x minus 10, obviously those graphs don't overlap, so that's not the right answer. If you come up and modify that to an x plus 6 and then change this to an x minus 5, again, not a match, although it looks pretty close. So then change this to x minus 6. Let me enlarge this just a bit for you all so you can kind of see it a little better. See if I can do that. Yeah, there we go. So that's x minus 6 and then x plus 5. Now you see that those two graphs perfectly coincide with one another. In fact, you can't see the red one until I turn the blue one off here in Desmos. And so that's one thing that you can do with these equivalent expressions. Make the graph of this and then graph these until you find the one that perfectly coincides and overlaps the original expression. All right. Let's move on to the next one that I wanted to work. And this was problem 13. This says for an angle with measure alpha in a right triangle, sine of alpha is 5 over 13 and tangent of alpha is 5 over 12. What is the value of cosine alpha? Now, why did I pick this one? I really honestly have no idea. What I would be doing on this problem is I would be making myself a triangle, a right triangle. I would be calling one of the angles alpha. And I know that that ratio is opposite over hypotenuse for sine, right? We're using SOHCAHTOA here with right triangles. And therefore, I'm going to assign the lengths of my triangle to this ratio so that the opposite side would be length 5 while the hypotenuse is 13. I would know by the Pythagorean theorem that that's a 12, or just know that 5, 12, 13 is a standard right triangle. Now it says, what's cosine of alpha? Well, cosine is adjacent over hypotenuse. It's 12 over 13. All right, so not going to use Desmos on that one. All right, number 14 is a system of equations. It says, which of the following values, if any, is the y value of the solution set to the system of equations below? Well, what I'll do here, students, is I'm just going to graph each one of these lines. These are two linear functions, and I'll come over here to Desmos and get rid of those calculations, and I'm going to use the graphing feature here. I'm going to do 2x minus y equals 7, and then the other one is negative 4x plus 2y equals 2. And you know that when you're doing a system of equations graphically, the solution is going to be the intersection point of the two graphs. And as I'm looking here, this looks like these are two parallel lines. I'm going to zoom way out, and indeed they are. And if these two lines never intersect because they're parallel, then there is no value of y or x that would make a solution to that equation. All right. Now, I do want to draw your attention to this important difference between Desmos and your TI-84, right? So here would be a TI-84 that we could use. But the problem with graphing on the TI-84, there's two problems with it really, is it's slow. It's much harder for me to graph things. I have to use just basically my thumbs as I'm typing things in. But notice that when you graph on the TI-84, you have to graph them explicitly. That means that you can only graph equations where the y has been isolated on one side. So even if I wanted to use a graphing approach on this system of equations, I would first have to do the algebra and solve them for y and then put them in the equation. But if I'm going to spend my time doing that, I might as well solve it algebraically. I really lose the advantage of using a graphing technique if I have to first rearrange the equations before I even put them into my calculator. Desmos doesn't care what the equations look like. You type them in as is, and they will make the graph that represents that equation, and that's it. And then you can look and see there is no solution. The next one that I had picked was this one. It says, which of the following expressions is equivalent to this? So they want you to expand that binomial to the third power. So you could take several approaches algebraically. You could do y plus 7 times y plus 7 times y plus 7, and then FOIL this and then multiply it by that. Or alternatively, what I'm going to do here, students, is I am going to use the same technique I showed you 2 problems ago. I'm going to graph y equals. Now I'm going to use x here because I'm graphing this as a function. So I'm going to graph y equals x plus 7 to the third power. Okay, and I see the function right here. Notice I just hit this home button right here. So if you've been doing some zooming in and zooming out and your graph is really out of kilter, you can hit that home button. It'll recenter the graph for you. So there's the graph that represents x plus 7 to the third. Then what I could do is I could graph my answer choices. If I think it's the first one, let's try x to the third plus 21x to the second plus 147x, and then plus 343. And we got lucky here because it looks like as you zoom in on this, that it is a perfect overlay. And if you turn the blue graph off, you'll see the red one is right underneath it. And so that is a perfect match right there. If it didn't match, well, then I could have come up and edited this second line to be the next possible answer choice and see if that was a perfect match on the graphs. So again, on equivalent expression problems, graph it as a function, graph each one of the answer choices, and be looking to see which of your answer choices produce a graph that is perfectly overlapping the original expression. Let's do another one. Well, I'm glad that this one popped up because this is a complex number problem. So they tell us that I is the square root of minus 1, and they want us to do the square root of 9 plus the square root of minus 16. Well, we know that that's a 3. And this, I hope that you know that if you have the square root of a negative, you bring that negative out as an I because of I being the square root of negative 1. And then you take the square root of 16, which is 4. So this is 3, 3 plus 4I right there. And that's going to be my answer. However, I want to show you something about Desmos. Now, I do assume that the version that they're going to have on the ACT is going to be the same version, or at least very, very close to the same version that we have here at their website. There are minor differences between the Desmos.com version of the Desmos scientific, or I should say the Desmos graphing calculator, and what you see on the SAT, but they're so minor you really don't know that they're there. But one of the features is that if you go to the graph settings and you click up here on this wrench, it says graph settings. When you click on that, a couple of things that there's only two things here that I would recommend that you'd ever fool with. One would be if you need to change your mode into degrees because you're going to take the sine, cosine, tangent of an angle in degrees. You don't want to be in radians mode, okay? Most of the time on the ACT, you want to be in degrees mode, okay? So that's one thing. But notice there's this thing called complex mode. If you turn complex mode on, what that's going to do for you, and we'll turn that settings off by clicking again on the wrench, is it will recognize the letter I that you type on your keyboard as the imaginary square root of minus 1. So if you did square root of 9 plus square root, let's get outside the radical and do plus square root minus 16, it's going to give you 3 plus 4i. It's going to go ahead and simplify that using the complex unit I for complex numbers. Okay, so that is a really nice feature right there. Will that be on the ACT? Is it on the SAT Blue Book version? I think it is. I probably would have heard if it was not. But do we really do complex numbers on the SAT? I believe we do. But that's how you would do that. Notice that if you did turn complex mode off, right, it's not going to recognize that you want to calculate. It's just going to say, hey, I can't take the square root of minus 16 because it's working only in the real number system at this point. So anyways, that is something that's very useful if you're dealing with complex numbers. I chose 23 just to show you, one way you can do some calculations here. If they want you to find f of 5 and find the number that's closest to it, you could type f of x equals 7e raised to the 3x plus 1. And I used function notation so that when I come down to line 2, if I do f of 5, right, it's going to go ahead and stick the 5 in for the x and give me the answer. Now, this is a very large number. You can see this. This is going to be 1, 2, 3. It's 22,883,000 and some change. And therefore, what's the right answer going to be here? It's going to be, which is closest to the value. Well, that's a small number. That's not it. That's 300. This would be 60 million. That's going to be 20 million. Right? This would be 20 times 10 to the 6th. Okay. So our answer is going to be C right here. All right. So you could use function notation as my only point right there. All right. Let's see what else we've got here. I think I had another one. Yeah, I want to do this one here because it involved fractions. This is number 32. Lawan sells 4 kinds of pies in his bakery. apple, pecan, coconut cream, peach. Of the pies he sold on Thursday, 1/4 were apple, 1/2 were pecan, 24 were coconut cream, and 8 were peach. How many total pies did Lawan sell on Thursday? Now, when I work this problem with students, I tell them to go ahead and use what we call a back solving method, where I'm going to use the actual answers to see if they give me the desired result in the scenario. In other words, I know that these are possible total pies right here. Every one of those is a possible value of total pies that Lawan baked on Thursday. So therefore, 1/4 times, we'll call it X. These are all X's, total pies. Those are going to be the apple pies. 1/2 of them, sorry, are pecan. So we'll say P. So we'll say 1/2 of those would be pecan. But then there were, for coconut cream, there were 24. And then there was peach, which was 8. So really what this is I'm going to build an expression in my calculator here. And I'm going to say 1/4, and I'm going to use a letter A. And I'm going to add a slider because I want to be able to change that value. So 1/4 times the number of pies plus 1/2 times the number of pies plus 24 plus 8. Okay. Now that, let's see. And now how many total pies did Lawan sell on Thursday? Now, actually, I think I'm not going to do this. I don't think that's going to work here. What I'm going to do is say, well, gee, if he sold 56 pies, let's start with 42. Let's see if that works. If he did sell 42 pies, I've got to take away 32. Those are fixed numbers. Okay, that leaves me 10 pies left. Now, 1/4, let's do it this way. If 42 is the right number, I would take 1/4 times 42, and that would be, let's try that again. So we'll come over here, get rid of this. 1/4 times 42 gives me 10.5 pies. That doesn't make any sense, that he would have made half of a pie. So I don't think, just by the fact that 1/4 times 42 doesn't give me a whole number of pies, that probably is not the answer. Let's try F, 40 pies. If he made 40 pies, 1/4 times 40 would be 10 apple. 40 times a half would mean he made 20 of the pecan, but he has a fixed number, 32, for the coconut and the peach. Now, when I add those up, I get 62 pies. I don't get 40 pies. So that's not going to work either. So I'm going to jump all the way up to 128 pies. Let's assume that he made 128 total pies. I would take 128 times 1/4. That would give me 32 pies. 128 divided by 2, or times 1/2, is 64 pies. And we have this fixed number, 32, for the coconut cream and the peach together. Now that does give me 128. So J is my answer. Okay. That one doesn't really come out to be, showing us how to use Desmos very well. But that's just kind of a back calculation. Let's see if there were any others back here. Yeah, I was going to show you this one, 42. Which of the following data sets has the largest standard deviation? Well, they don't really expect you to calculate the standard deviation for these 4 sets of numbers. They want you to know what the definition of standard deviation is, and then look and see which one would have to be the largest. Standard deviation for a set of numbers is telling you the typical distance of the numbers from the average, or from the center. In other words, the data set that is the most spread out, left and right, is the one that is going to have the largest standard deviation. This one has the smallest standard deviation. It has no deviation at all. Its standard deviation would be 0. This one here has the biggest spread because you've got 0, 0, 10, 10. So the average is going to be right in the middle at 5. And it goes 5 to the left, 5 to the right. So this definitely has the largest standard deviation. I was just going to show you that if you wanted to calculate the standard deviation, it's possible very quickly in Desmos. If you type, I believe it is STDEV, standard deviation. I believe that's the sample standard deviation. You could type all of the numbers in, and it will do the calculation for the standard deviation. Now, is that the sample or population standard deviation? I'm not sure. It's not going to really matter. If you do the standard deviation for 0 and 1, I'm putting just commas in between each of the data sets, it's got a slightly lower standard deviation because it's not spread out as much as those 4 numbers are from each other. And then you could also see that the standard deviation here is 2, 3, 5, 7. That's even lower. And then standard deviation, when there is no deviation, they're all 5s. You can see the standard deviation there is 0. Okay, so it does have some statistical features in it. So the bottom line is that if you are going to take the digital version of the ACT on February 14th, yeah, you would want to work some problems using Desmos for sure, and learn some of the capabilities of it. There are lots of videos that are on YouTube that teach you all the different techniques for the SAT, because it's been over, I think it's been over 2 years now that we've had the digital SAT out there. So a lot of resources are out there on how to use SAT to its maximum advantage on the SAT. You could use some of those and look at them just so you can learn the techniques of using Desmos as a graphing calculator. All right, now the other part then that I do on Sunday nights is I do answer any questions that have come in. So I am going to check my inbox to see if we have any. If not, we are going to end our session. So let's take a look. All right, seeing no questions that have come in, that's going to be it for tonight, students. So next week, Sunday at 8 o'clock, watch for the thumbnail. I will show you what the topic is going to be next week. It's probably going to be something related to either the SAT or the ACT, because we are in now a heavy testing season with the ACT coming up in just a few weeks. And then right after that, in the second week of March, we got another SAT coming up. And so everybody's getting ready for that. Okay, everybody, have a great week ahead, and I will see you all next Sunday.